Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. Given this linear system with parameters q and t, determine the value of q that makes the system singular. Then determine which value of t makes the singular system have infinitely many solutions. And finally, within that infinite solution case, find the specific solution where z equals 1. Let's rewrite the system as an augmented matrix so elimination reveals the pivots clearly. A zero pivot is the elimination signal for singularity. First, eliminate x from row 2 by subtracting row 1. Now, the first column below the pivot is cleared. The next pivot candidate is the 3 in row 2, column 2. Next, eliminate y from row 3 using row 2. This creates the third pivot position in the bottom right of the coefficient matrix. In triangular form, pivots sit on the diagonal. These control singularity. We'll focus on pivot 3. If it becomes 0, the matrix loses a pivot and becomes singular. Singularity happens exactly when a pivot becomes 0. Here that means the 3-3 pivot. Setting pivot 3 to 0 forces singularity. That's the parameter value that makes the system singular. After the pivot disappears, the last row decides whether the system is consistent. If the last row becomes 0 equals non-zero, we get a contradiction. If it becomes 0 equals 0, we get freedom, hence infinitely many solutions. So infinite solutions require t equals 5. Now we have a singular system that is still consistent, so it has infinitely many solutions. The third equation now matches what elimination produced. It no longer creates a new pivot. From the infinite family, we choose the member with z equals 1. With z fixed, the third equation determines y immediately. Now, use the first equation to find x. The check confirms we're consistent with the second equation too. Elimination reveals the pivots, and the last pivot plus the last right-hand entry tell us singularity and consistency. Those are the final results. When it's singular, when it has infinitely many solutions, and the requested specific solution. Watch the next video to learn more. Next, we'll connect these pivot and consistency ideas to geometry, so you can see why contradictions and infinite families happen.